All right, so today what we are going to do, as I mentioned when we were going through some of your homework questions, is we're now going to try to come up with a formula for these patterns, so that instead of just having to add 3 each time, we can plug in the number directly to find the term that we're looking for. And there are 2 parts to these formulas. The first part is very, very simple, or it should be. And so I've got a couple of examples that we're going to do up here that illustrate that. So let me get this stuff, let me scoot this down a little bit. Yes, that's an n, and n is in fact the variable.
There we go.
All right. So let's look at number 1. And the first thing we're going to do is we're going to fill in the blanks here. So the first term, hello, yes, thank you, is -4. The next one's -3, then -2, then -1. And so the pattern is very easy. What's the 5th term going to be?
0.
0. And what's the 6th term going to be? 1.
1.
Okay. What is the pattern that you guys saw going on there? It was going up by 1 every time. So -4 to -3, you got there by adding 1. Got here by adding 1, adding 1. And so we continued to add 1 and we got it going. All right? Okay? Let's look at the next one. Okay? What are the 2 missing terms in that sequence?
2.
What comes next? 1, 5, 9,
13.
13,
17.
and then 17. Good. And again, this is not supposed to be the difficult part. You're supposed to be able to look at this and say, hey, we went up by 4, and then we went up by 4, so we're going to keep going up by 4 each time. Okay? So that is easy. That's no big deal. Okay? The question is, how can you take the fact that this went up by 1 every time and relate it to this formula? How can you take the fact that this went up by 4 each time and relate it to this formula? Where do you see a 1 in this formula that you see a 4 in that formula, Mackenzie? On the end, yes. And so since this went up by 1 every time, we know we're going to start with 1n. Okay? And since this went up by 4 every time, your formula is going to start with 4n. Okay? So that's the first part, is to recognize that the amount that it goes up each time tells you the number that goes in front of the n. Everybody good with that? Okay. It also holds true if you are going down. It wasn't just a positive thing. To get this one here, I went down 2. To get this one here, I went down 2. So the next one would be down 2 to -3. Boys, please stop. Okay? No. I don't care. I want you to stop and pay attention. Okay? This is important. So it went down by 2 each time, and so same as the other thing, we went and had a -2 in front of the n. Okay? So that part is the easy part. And hopefully, I mean, my only concern is some of you aren't really paying attention, which is bad, because this is a really key piece to what we're going to be doing for a long time. You understand how to get the number in front of the n? Okay. The next question then is, how do we come up with the number that's after it? Okay? And there is a couple of different ways that you, well, let's do this new one. There's a couple different ways that you can come up with that. So let's come up with a pattern for this sequence right here. Right, first thing you notice is that we're going up by 7, up by 7, up by 7. And so that tells me that the first part of my pattern or my formula is going to be 7n. Okay? And if you have missed that part of the learning target already, then you need to raise your hand so I can explain it to you. Went up by 7 each time, so we start with 7n. Okay? All right, but this is incomplete. because the first term of my sequence is 20, but if I plug 1 in here for n, what do I get? 7. So the next thing you have to ask yourself is, what can I do to the 7 to get the 20 that I want? Add 13. Okay? And then it works for every single one of them, because now if I take a look at this and plug 2 in there for n, what's 7 times 2? 14 plus 13 makes 27. 3 into there is 21, plus 13 makes 34. So now by adding that 13, bless you, we've made it so that they match up perfectly. Okay? So one way to do that again is to look at what happens if I plug 1 into there and adjust it by either adding it or subtracting it so that I get to the number that I want. Okay? There's another way that you can find a 13 in this pattern, which somebody got last period. The number 13 is not up there right now, except for in the formula. Where would the, what? Right, good, excellent. If I go backwards to 0, okay, since I'm adding 7 each time when I go this way, if I'm going to go that way, I would have to subtract 7. And that would tell me that at 0 it equals 13. And so that is another way that you can find out what this number is right here. Okay? So the number in front of the n is based on how much it goes up and down each time. And then the number that you add or subtract, you can either do by kind of a guess and check, or you can work your way back to 0 to find out what that is. Okay? Does that make sense? All right. So if we did this one right here, take a second, don't say it out loud. Take a second on your own. Alex, you included. Take a second on your own and see if you can figure out what the formula would be for these nombres. All right, what's happening to the numbers each time? Going down by 5, so the first thing is negative 5n.
Plus
Yes.
12.
Plus 12, good. Two different ways to get that. One is I can plug 1 into here and go negative 5 times 1 is obviously negative 5. So if I want to change that into a 7, I have to add 12. The other way you can do it is like Curtis said, you can go backwards to 0. So instead of subtracting 5 each time, you add 5 each time. And that'll tell you that at 0 you get 12, and so that means you have to add 12 on. Okay? Make sense? All right. Unfortunately, this doesn't always necessarily work out because not all patterns involve adding and subtracting a number each time, but we'll deal with those more tomorrow. Let's do a geometry one. This is kind of a strange one, but we'll just work our way through it. If you place 200 points on a line, how many non-overlapping rays and segments do you get? Okay? And so we're going to solve this problem by breaking it down into a simpler problem by first figuring it out for 1 point, 2 point, 3 points. And then we're going to come up with a formula because I don't want to make this table go all the way to 200 points. That would be a drag. That would take me a long time. So the power of having a formula is that instead of having to just continue your table out there, you can just plug 200 into your formula and then you know your answer. All right? So let's start with 1 line and 1 point. How many non-overlapping rays can you have if you have 1 point on the line? 2, because you have a ray that starts at A and goes to the right, and then you can have a ray that starts at A and goes to the left. So that is a total of 2 rays. Okay? How many segments would I get?
1.
Somebody that said 1 or 2, name a segment on that line.
Segment A.
A is a point. Name a segment on that line.
There is none.
There is none. We need 2 points to make a segment. So in this case, I would have 2 rays, no segments, for a total of 2. Okay? Yep. All right, let's add another point. And let's call it B. All right, now this is a tad confusing because of the non-overlapping thing. How many non-overlapping rays can I draw on that line?
2.
2, right, good, still 2. Because I can start at either A or B this time. But if I start at A and go to the right, yeah, I'm overlapping with B, so now I can't start at B. All I can do is start at A and go to the right, start at A and go to the left, and there's my 2 rays that make up that entire line. I could have started at B and gone each direction, and then I would have killed the A ones, but either way I would have come up with 2 rays. How many segments do I have?
1.
Solamente uno. What is that segment called?
Segment AB.
Segment AB. And so now if we add those together, my total is 3. So hopefully some of you more astute math students are looking at this and you're starting to see the hint of a pattern already. What do you think is true about the number of rays?
It's
It
always
seems to be staying at 2. What do you see is true about the number of segments? Going up by 1 each time. So let's check the next one and see if that is in fact the case. How many non-overlapping rays do I have now? 2. For the same reason as before, I can start at any one of these 3 points. But once I go to the left and to the right, then the whole line is covered, and so I can't use any of the other points up. How many non-overlapping segments do I get?
0.
0? 2. Someone who said 2, name the 2 segments that you think we have. A, B, and AC.
What about segment CB?
But I can't use that because they overlap CA and AB, okay? So 2 is correct. I would have 2 segments there for a total of 4 altogether, okay? So now I think that you would believe me if I said we have enough data here, we can just figure out the pattern, and it's an easy one. If I have n points on here, how many rays am I going to get?
Minus
2. Always 2, okay? How many segments will I have? Well, I just want for n. I want the formula first. You're right for this problem here.
N minus 1.
N minus 1. Good, because what you should notice is that the number of segments is always 1 less than the number of points. So if my number of points is n, then 1 less than n is n minus 1. All right, what do I get if I add those together? Combine some like terms for me. N plus 1, because 2 and negative 1 make positive 1, so that will give me n plus 1, which we could have seen if we looked directly at the total. All of these totals are 1 more than the number of points, okay? So now Nikki's ready to solve the problem. If we have 200 points on the line, how many rays will we have? 2. How many segments will we have? 199, for a total of 201. Okay? So sometimes you have to break it down into a little bit simpler problem. Instead of drawing a line and trying to put 200 points on there and counting all the things, if you go back to the very beginning, you can see a pattern and then use that pattern to figure out